Okay, this is my first attempt at standard 0.3. I decided to do number 2. We are asked to show that the trace of a matrix, of a 2x2 matrix, can be given by the sum of the eigenvalues of that matrix. We are asked to show that the determinant of a matrix can be given by the product of the eigenvalues. And then we are asked to show that both of these work for this following matrix A. So I started off with the general matrix here, the A, B, and C, D matrix. The first thing we have to do is find the characteristics polynomial, find the eigenvalues basically. So we set the determinant equal to 0, we do some computational, and we come to here, where we notice that we have the trace of A there and the determinant of A there. So we plug them into down here. Then using the quadratic formula, we found our two eigenvalues right here. So I decided to do B first. So here I multiplied the two eigenvalues together. You can see that these two terms cancel out, and what you're left with is this first term and this second term. Continue going. Adding these terms together, they cancel out, and then we get the 4 determinant of A over 4, which gives you the determinant of A, thus proving the theorem for B. Then A, we want to prove that the sum of the eigenvalues will give you the trace, so we simply add them together. We notice that these, the second term and the third term, cancel out, and we're left with 2 times the trace of A over 2, which just gives us the trace of A, thus proving the first theorem for part A. Then lastly, we start with this matrix. I used an online calculator to find that the determinant of A is 2, the trace of A is 3, and that these are the 3 eigenvalues. Thus I set the determinant of A, which equals 2, equal to multiplying all the 3 eigenvalues together, and I got 2. And then over here I set the trace, which is equal to 3, equal to the sum of the eigenvalues, and I got 3, thus proving the theorem for this matrix.